Okay, so this is the quiz or chapter 13 test review, as I go through it, just kind of keep in mind that you can put a lot of information on your unit circle. I would stay away from doing example problems, but maybe like we talked about at the final first semester, giving yourself some instructions about how to handle certain situations. I think that's a very effective way of being successful. Question number 1, you're not allowed to use your circle or any information on. You have to memorize this. It's that you have to use O, A, and H to define all 6 trig functions. And it'll be written in this format. Sine of theta, cosine of theta, and tangent of theta. And then down below, cosecant, secant, and cotangent. Now I stack them like this so that it's easy to remember which ones are paired. It's just up and down. So sine, we often use the phrase SOHCAHTOA, and so is S-O over H. S-O-H is so. Ka is C-A-H. And then TOA is tangent O over A. SOHCAHTOA. Some will literally write it S-O-H, C-A-H, minus C, and then T-O-A. SOHCAHTOA. However you can, you need to memorize that information, and then that when you come down, you're going to flip these over. Cosecant is H over O, secant is H over A, and cotangent is A over O. This information is the only piece that you physically need to memorize. Now when we go to the unit circle, okay, you might also want written down that sine is also the y value, cosine is the x value, tangent is the y over the x, cotangent is the x over the y, secant is the r over the x, and cosecant is the r over the y. Now, you know that r is always 1, and so that's useful, but you might need to memorize those for using the unit circle. You might not. It depends on how comfortable you are with it. But only the OA and H is necessary for problem 1. Now you can pull out your unit circle. Again, I will check that off as correct or incorrect before you pull your unit circle out. We'll try to make that happen as quickly as we can. Then question number 2, you have a right triangle with theta up there. You have 10 here and 8 here. And you're asked to find all 6 trig functions, which is what you did above, but this time for this triangle. The only thing that's weird is we're missing this side over here. And so we're going to have to use Pythagorean's theorem. A squared plus b squared equals c squared. But when we do this, we have to keep in mind that the side that is opposite of the right angle must be c. So that's 10 squared equals, we'll say 8 squared plus a squared. And if we solve this, we're going to minus 64. Okay, it's really important that we subtract there. A squared should be 36, which means A is 6. So I'm going to write 6 right there on that side. And now I need to acknowledge which sides are which. So from theta's perspective up here, this would be the opposite side. Of course, this is the hypotenuse. That makes this the adjacent. So when I go to do SOHCAHTOA, I can actually follow that rule. Now the sine of theta is supposed to be O over H. So that would be opposite, which is 8, over hypotenuse, which is 10. But that reduces. So really this should be written as 4/5. Okay, so get rid of the 8/10. We reduce if we can. You can't always reduce, but when you can, you should. And since I'm here, the cosecant of theta would be 5 over 4, the upside down version. And I'm going to go to cosine of theta, which is the adjacent over the hypotenuse, which would be 6 over 10, but that reduces to 3 over 5. Making the secant of theta 5 over 3. And last but not least would be our tangent and cotangent. Tangent is supposed to be opposite over adjacent, which would be 8 over 6, which reduces to 4 over 3. And then cotangent is 3 over 4. This right here is the answer to question number 2. When we go to 3, we're going to keep this triangle. Question 3, maybe you didn't quite catch the way that this is worded, but it says, for what value of theta? In other words, what is theta so the triangle above is possible? So if you want theta to sit there and have this 6, 8, 10 triangle exist, there must be a specific angle, okay? You change the angle, the sides change, and so this is really important. If this information is true up here, then I should be able to use my calculator to figure out what theta is. It does not matter which one of the top three you pick. I'm just going to grab cosine. But let me make this clear. Sine works and so does tangent. But I'm going to take cosine just to show that it works with any of them. Cosine of theta equals 3/5. Well, ignore everything else. That's a true statement. How do we get theta alone? To remove a cosine function, or any trig function, you have to use its inverse. So I'm going to cosine inverse both sides. And that should leave theta alone. So I'll grab my calculator. And one of the first things you're going to need to do when you turn your calculator on is check the mode. A lot of them will be reset, so we're going to come down here. You notice that mine is already in degree mode. That's great. If it's not, I slide over, I press enter. It becomes degree mode. So I can go back to the main page, and I'm going to do the cosine inverse of 3/5. And press enter. I get 53.1 degrees. That's all that's asking you to do. The reality is, if I gave you enough information about the triangle, you should be able to find all the rest. If you needed to now find the other guy, obviously you've got a 90 here, you subtract from 180, and you'd find the other guy is 36.9. But you don't really need to do that. I just want to know that, can you go that last step and get the angle? All right, after that, our job for the next two questions is just conversions, okay? And so what we're going to do is we're going to do question 4 and 5 close by each other because they're very similar. We have 285 degrees, and then we have 4 pi over 9 radians, okay? So we want to convert these to show we can get back and forth between the two varieties. The linchpin between radians and degrees is that 180 degrees equals pi radians. And so that's our conversion factor. We're going to use 180 and pi in a fraction next to both of these. The question is, which one goes on top, which goes on bottom? We always need to cancel something. So up here, I could cancel the degree unit if there's one on top and one on bottom, meaning that pi stays on top. Down here, I'm going to cancel the pi that is usually referred to as part of the radian, and I'll put the 180 degrees up top. The bottom one is actually the easiest to calculate. It just goes into the calculator. And I'll show you how that looks. It should just be 4 divided by 9 times 180. And we press enter, it comes out at 80 degrees. Okay. The other one's a little trickier, only because we don't actually put pi in the calculator. Notice the 285 is on top of a fraction. It's in the upper part. I will divide it by the 180, which is in the bottom, and then I'm going to press this into a fraction. So math, frac, enter, I get 19/12. Notice I never used the pi because I'm treating it a little like a variable. So I'm going to write, I said 19 pi over 12. That would be the way we'd write that. Now if you wrote, another way to write it would be 19 over 12 times pi. That would work as well. It's not wrong, it's just different. Not the way you'll see it in the unit circle, but it's still correct. Okay, so speaking of the unit circle, the next place we need to go is to the unit circle. So we're going to pull this out to help answer a couple of questions. All right, so, whoops. All right. For the next couple of questions, as we go to the unit circle, we're going to try to do this without using decimals. That's one of the things that's in the instructions. Number 6 says the sine of negative pi over 3. Now, I could convert pi over 3, negative pi over 3 into degrees, just like we did in question number 5. But I can also just look at the unit circle. These ones that say don't use a decimal will work on the unit circle. So if I just look for regular pi over 3, it exists right here at 60 degrees. So there, it's converted. This is negative 60 degrees. So I need to go down from 0, I need to go downward 60 degrees. Well, if you know anything about the circle, you know there's 360 degrees in it. and getting from 360 to 330 is only 30 degrees. But getting down to 300, that is 60 degrees down from 360. Okay, that's just figuring out where I am. Now I know I'm in this spot. This is where the information comes from. Earlier we talked about how sine is defined not just as O over H, but there's also another value for it. It's the y value, okay? So I need to know the y value at negative pi thirds. If I look closely, there's an x and there's a y. The y value is negative root 3 over 2. Now some of you will say, oh, I could just put it in the calculator, Mr. Welch. Well, first off, you could, and if your mode is in degree mode from the triangle problem above, you'd be wrong. That would not calculate it correctly unless you first converted it to degrees and used negative 60. The second thing is, this comes out of the calculator as negative 0.866 dot dot dot. Unless you memorize the different decimal equivalents, you're not going to be able to keep track of it without using the circle. I'm a big proponent. You should use the unit circle and know how to find your way around it. Let's do blue for number 7. So ignore all the purple for a minute. Number 7 says we're going to do the cosine of 150 degrees. Okay, so first thing I need to find 150. Now this one's nice because it's in degree form. So there's 150, and there's all the information that I need about 150. I come back over here and say, now what was it we defined x or cosine as? It was a over h, which I also said was equal to x value. So this is just the x value. Okay. So now I'm looking for the x value at 150. That happens to also be negative root 3 over 2. Now that's a coincidence that I picked two problems that had the same value or same answer. But if I were to take the calculator and do the cosine of 150, notice I'm in degree mode from before, I get that negative 0.866. Now, again, if you memorize all those decimals and which ones are which, yeah, I guess you can use your calculator. But the unit circle is pretty straightforward. Find your spot and then use the information that you're asked for. So sine is always the y, cosine is always the x, tangent is the tricky one. Okay? Tangent's going to require a little bit more work from us because it's a combination of the y and the x. Or more specifically, it is the y divided by the x. So here we have the tangent of 4 pi over 3. Pi over 3. It is the y value divided by the x value. That is its definition. Yes, it's O over A, but that also translates to y over x when we look at the circle. So first thing I've got to do is find 4 pi over 3. Now if you're not comfortable finding them on the circle, yes, convert them. You'll find them that way. But now I have to stack the y value, which is negative root 3 over 2, over the x value, which is negative 1/2. Something I want to encourage you not to do is do slanted fractions like they write. I wouldn't write negative root 3 slash 2 over negative 1 slash 2. The reason I don't do this is because it's hard to reciprocate. It's hard to see it visually flipping. I like this version over here because if I times by negative 2 over 1 and they're stacked like this, it makes sense that the denominator cancels. I'm left with a negative times a negative. Right, all this has gone down here. And notice the 2 cancels the 2, the negative cancels the negative, and I'm left with just root 3. Okay, that's not something you're going to identify easily out of the calculator. So again, stacking the y and the x, do you know how to clean it up? If a root's in the denominator at the end of your problem, how do you get it out of the bottom? Those are questions you could certainly come and ask. Okay, so that's how we work with it when we know the angle. Okay, this is really important. We always had theta. It was given to us each time on 5, 6, and 7, or 6, 7, and 8. On 9, 10, and 11, we don't have theta, and we're going to be asked to find it. So we're going to work backwards this time. Instead of going to the angle and saying what sine, cosine, or tangent is, we're going to do it in reverse. So number 9 says the sine of theta equals 1/2, positive 1/2. And our job is to find all of the locations where that's true. Okay, now, if I'm looking at this circle, I'm starting to look and realize that sine is supposed to be the y value. So I'm only going to look at y values. Okay? And when I look at the y values, I'm looking for y to be 1/2. You'll notice right here at 30 degrees, the y value is 1/2. So right away, my degree answer is going to include 30 degrees. My radian answer has to include pi over 6. Notice you got pi over 6 right there and 30 degrees there. Now I want to find other places that have a y value of 1/2. Remember, guys, this is an actual grid. Okay, this is an xy axis. Here's your y-axis. Here's your x-axis. Okay, and this point right here just happens to be 1, 0. Okay, so when we think about the actual coordinate plane, we realize that y values staying the same. Okay, if this is my y value, then it has to be right here. There is only one other place on the circle that has the same y value, and if I just track it across right there, do you notice that this right here has the 1/2 as a y value? If I had to move up or down, that would be bad because that would change the y value, which is always measured up and down. Okay, and so we know that when we want the y value to stay the same, we're going to go straight across horizontally. If you're uncomfortable, just keep checking all of them. Typically, not always, but typically you get 2. So here, our second degree answer was at 150 degrees, comma, and we also had, turns out to be, it's a 5 pi over 6 that's right there. Now this might seem weird, but let me ask you a question. How many 30s does it take to get to 150? It's times 5, right? Well, how many pi over 6 does it take to get to here? It takes times 5. So there's a consistency in the way we would find the second one, okay? Now, if I change what sign equals, it's not always times 5, but when we're converting from 30 to 150 or from pi over 6 to 5 pi over 6, there is some equality there. So that is a sign problem. We always fold that left and right like a book. All right, let's look at something that isn't a sine. Let's look at a cosine. So question number 10 asks us to find the theta. So cosine of theta equals, I think it's equal to -1. Sorry about the handwriting, it got really bad there for a second. All right, so cosine of theta equals -1. So first thing I'm going to do is I'm going to go and look for a place where the x is -1. Well, if this is the y-axis, then everywhere on there is 0, okay, for x. And I could go right and left. Going left would make it negative. So I'm going to look over here, and I'm looking at my x values specifically. Right here, I find a place where -1 is the x value. So my degree answer is going to involve 180 degrees. My radian answer will be pi. Okay, so far. Now, I need to go one last step. I need to make sure there isn't a second answer. When sine or cosine equals 1 or -1, that's typically when you're only going to have one solution. However, let's make sure by doing this. Can we all agree that on the x-axis, that point right there is -1? Okay, that's what we're claiming here from earlier. So if that's -1 on the x-axis, moving right and left would change that. I can't move this way, but I can move up and down. Okay, I can move up and down because the x will stay on the same line. However, if I move up and down, I leave the circle. I'm not going to stay on the circle. So this is a case where if I move away from this point, I'm off the circle and I no longer have solutions. So this is one of the rare cases where we have just one answer. Okay. Well, let's look at our last type, which is the tangent. Again, like the sine and cosine typically, it's going to have two answers most of the time. And so let's start with the tangent of theta equals √3. Okay, so this is where it gets a little trickier. If you get comfortable with the circle, you spend time with it, and you've spent some time thinking about it and looking at the numbers, it's not bad. Because there's only one way you're going to get √3 from these numbers. And that's if √3 shows up in it initially. If you realize that tangent is y over x, okay? Well, a root 2 over 2 over root 2 over 2, this is going to equal a tangent of 1. So I don't like that. Using 1 and 0 is never going to produce a root 3. Same thing up here. I'm left with this option and this option. Now on the test, maybe I do give you the tangent of theta is 1 or negative 1. And that would happen at pi over 4 or at 7 pi over 4, something along those lines. We could see those ones where we're going to get a 1 because the x and y are the same. But we could also just try the y divided by the x on some of these. So let's take 60 degrees for instance. If I took the tan of 60, rather, it'd be the y value, which is root 3 over 2 over 1 over 2. I'm trying to prove, does this give me the right answer? So I times this by 2 over 1. The 2's will cancel, and I get root 3. Now, is that the answer I was hoping to get? Yes, it is. So right now, I know that 60 degrees is one of my answers, which means the radian of that would also be an answer, which is pi over 3. Now, I need to find another place that has the same x and y values. So I decided that one was no good. Okay? So I like this being the y and this being the x. Now, if I look for other places, I can find one like it that's right here. The only problem is a negative and a positive. If you stack a positive and a negative together, this would be negative root 3, not positive root 3. So this is out. If I come down, I keep looking for that same combo. Notice this, it's the wrong order. The x is supposed to be the 1/2, the y is supposed to be the root 3 over 2. So I don't like that. I already said those are no good. What about this one? It has the same y, it has the same x, but it's got a negative and a negative. Well, the negative divided by negative is positive, so this would come out as positive root 3. So I can confirm this is my second choice, 4 pi over 3 and 240. Now, if you look back at question number 8, you were doing the tangent of 4 pi over 3, which essentially, it gave you root 3, correct? So you could validate that right away. Now, if you're someone who's struggling getting around the circle and getting comfortable with stacking them, on a tangent, or really any of these, you can find one of your answers using the arctan or tan inverse. So here's what we're going to do. I'm going to go ahead and do the second tan of the square root of 3. Okay, so this is what we were looking for. Whoops. Okay, so this is what the test was asking you for. It tells me 60 degrees. Great. But I still have to come to the circle and figure out where the other one is. Now, the nice thing about tangent is it always follows the diagonal line. If you look at where 60 and 240 are, they're off by 180 degrees. That will always happen. Okay? All right, so that should take us through the first big chunk of the test. Once we get done with 11, the rest of it is about law of sines, law of cosines. That's it. And I hope that you have them written down on your unit circle or that you memorize them. To be honest, if you've been doing the homework, you probably have them fairly memorized. Now, you also might feel less confident and want to be positive, but generally speaking, you're probably fine. All right, so let's look at question number 12. You're given a triangle. They tell you that this is big B and it's 21 degrees. This right here is 32 and this is 17. Here's A, here's C. Now keep some things in perspective. That's little c, that's little b, that's little a. If you can't keep track of the organization of the lettering, you're going to struggle. The reason this is little a is because it's directly across from big A. Big C, big B, little b. It's just directly across. So your job is to solve the triangle, which means give me all the information. All right. little b is 17, big B is 21 degrees. Label degrees only because I don't ever want you getting an angle and a side mixed up. And then little c is 32. Okay? And so our job right now is to go in and do a law of sines. The reason I know it's law of sines is because I have both sets of information about B. If you have both sets about A, B, or C, it's a law of sines problem. We only use law of cosines when you don't have a complete set. So because I'm going to start looking for angle C, I'm going to say that the sine of big C over 32 equals the sine of big B, which is 21, over little b, which is 17. Now some of you are going to say right now, Mr. Welch, we're supposed to avoid big angles, and 32 is going to create, this right here should probably be an obtuse angle. To be honest, this test review is set up in a way that you're kind of stuck. You don't have a choice. And so all you're going to do is just go through the regular process, pretend that it's supposed to be acute, and if something doesn't work out, we'll adjust it. But it should work out nicely on the test. The student who wrote the test review might have made a mistake, and anyway, we're okay. But what we're going to do is we're going to times by the 32. We have the sine of big C equals, and all this is going to go in my calculator. So again, my calculator is still in degree mode, so I'm good. Sine of 21, oops, close the parentheses, divided by 17 times 32 equals 0.6745. 0.674, I guess it'd be 46, if I round that correctly. But I'm going to go straight back to my calculator. I know to get C alone, I need to do the sine inverse. So second sine, second answer, grab my answer from above, 42.4. Okay, so I'm going to do sine inverse, and that gives me a 42.4 degree angle. Now, right now, I want you to understand, it is possible that angle could be wrong, but we're going to check one thing at the end. Let's go ahead, because we don't know anything about A, there's a good chance it's going to work itself out. I know I have to have 180 degrees to get big A, so I'm going to take 180 minus 21 minus 42.4 equals 116.6. 16.6 degrees. So there's my obtuse angle. What that means is little a had better be bigger than 32 in a big way. And so because I'm now looking for little a, I'm going to flip this law of cosines over. I'm going to say little a over the sine, over the sine of 116.6 equals, and we're going to go with little b, 17 over the sine of 21. To finish this, I need to times by the sine of 116.6. I'll get rid of that and leave little a alone. So I'm going to grab my calculator. I'm going to type the sine of 116.6 times 17 divided by the sine of 21. And if I press enter, I get 42.4. Is that bigger than the 32? Yes. And to be honest, maybe we could do some more investigation to see if there's a secondary triangle that could be built from the original measurements. The answer is probably, but I'm not going to dig too deep into that right now. On the test, it should be pretty clean. It should come out pretty well. So I'm going to be okay with this. This is a triangle. It does work. There's a possibility that I could draw a triangle where A is actually acute and smaller if I let C be obtuse. But we're not really going to go through that right now. Let's look at our last option, or our last question before the bonus, number 13. You're given a triangle CBA 43, 35, and this is a 96 degree angle. So of course I gave you the obtuse angle of this one, so there's no question as to what's biggest. But we have capital A is unknown, capital B is unknown, capital C is 96 degrees, little a is 35, little b is 43. and little c is unknown. I can't use the law of sines because I don't have all of the information about one letter. But I do know enough to use the law of cosines. Now, the law of cosines can be written in 3 different forms. Because of the fact that I want little c, I'm going to start with little c squared equals little a squared, which is 35 squared, plus little b squared, 43 squared, minus 2 times each of those numbers, 35 times 43 times the cosine of the same letter I started my problem with. Since it's a c, it'd be capital C, that'd be 96. Now there are no variables on the right-hand side, so all of that gets thrown in the calculator all at once. So here we go. We start with 35 squared plus 43 squared minus 2 times 35 times 43 cosine of 96. Notice I didn't stop until I was all the way down to the end of the problem. I get 3388. 3388, and to finish solving for c, I take a square root. So I go back to my calculator and I square root the number above, and I get 58.2. All right, so 58.2 degrees, or it's not degrees, what am I kidding? 58.2 is the side length. Notice it is the biggest, which makes sense for the 96-degree angle. Now I have both c information. What that means is I can now use the law of sines, which is a little bit easier. It's not going to matter which angle I go after because I already know c is the biggest. But just out of habit, I'm going to go for the smallest. So I'm going to start with a. Sine of big A over 35 equals the sine of 96 over 58.2. If I times by 35, then I get the sine of A equals some number. Well, figure out what that number is. Sine of 96 times 35 divided by 58.2 is 0.598. 0.598. Of course, we need to do the sine inverse to that. And so to get capital A, we just sine inverse our previous answer. And we get 36.7. So here I'm going to go 36.7 degrees. To finish it out, all I have to do to find capital B is subtract from 180. So 180, whoops, 180 minus 36.7 minus 96 is 47.3. One last check. Smallest side, smallest angle, largest side, largest angle. All right. This has been great. We do have one last little thing I'm willing to give you points on. It's can you use the law of cosines? This is the bonus. Can you use the law of cosines when you're looking for the angle? Now, this is not harder than normal. It's just that there's a lot of little places you can make silly mistakes. And so what we're going to do is we're going to look at this triangle that's given. C, A is over here, and B is here. 34, 27, and 19. Okay, you are being asked to find angle A. That's what I'm asking for. And so, because you don't have any of the sides, you just have the little letters, little a, little c, and little b, you still have to use the law of cosines, but the solving is going to be a little bit different. We do know all sides, so we're going to start, because we're trying to find big A, we're going to start with little a. So we're going to start with 34 squared equals the other two sides, 19 squared plus 27 squared, minus, remember it's 2 times those two numbers, 19 times 27. I have no problem with you just writing this down in your unit circle. Make sure that you're really careful about the notation and the lettering. It's in the book, it's in the notes. You're welcome to ask me in class. 27 cosine of big A. The key here, guys, is to realize that all of this stuff is stuck together as a big multiplication problem. This stuff here is plus, or it's an addition problem. There's a distinction between them, okay? And so if I wanted to move the 19 squared and the 27 squared, I could do those by subtraction right away. And that's what I will do every time. I'm going to subtract those two values over, grab my calculator, 34 squared minus 19 squared. And the nice thing about doing it this way is I don't have to carry around a bunch of numbers. I just throw it in the calculator and let the calculator evaluate certain pieces of it for me. So this turns out to be 66 equals. Now this also, I'd like to just turn it into one smaller multiplication problem. So I'm going to times these three things together and stick it right next to cosine, still implying that a multiplication has to occur. So I'm going to take negative 2 times 19 times 27. And I've got a little problem. I come back and hit my times symbol right. Times. All right. If I do that, I get negative 1026. Notice I still have the cosine of big A there. I haven't tried to separate them. Now, how is the 1026 connected to the cosine? This right here is still a multiplication problem. So I'm going to divide by negative 1026. I get the cosine of capital A equals some number divided by that. Negative 0.064. Negative 0.064. And to solve for A, I'm going to take a cosine inverse. So capital A in my calculator, second cosine, come up, grab that number, comes out to be 93.7 degrees. A equals 93.7 degrees. Well, guys, that is how the test is built. That's how it's structured, what's expected from it. Please take your time. Be cautious, be prepared. Write on your unit, circle what you need, and I'll see you in class.